So this is the bench setup for our demo today. We can see the evaluation board, the CCU102, and the RF transceiver board from Texas Instruments, along with the power amplifier from Skyworks. So this is the ZCU102 board. The Zynq UltraScale MPSoc will host the RF IP for CFR and DPD, and also the connectivity IP to the transceiver. So this is the transceiver from Texas Instruments. This is an AFE 7769 device. It supports up to 600 megahertz TX and feedback bandwidth to support the expansion, and JESD 204 for connectivity to the FPGA. And this is the Skyworks PA. We are using a Sky 66318-21. So this is a 200 megahertz PA capable of delivering up to 28 dBm average output power, 3.3 to 3.7 gigahertz. So for the rest of the demo, we will focus in on the DPD demo GUI and the signal analyzer to measure the performance. So this is the DPD GUI. We can set up the test signal here. I've got 5 LTE-20 carriers here, total 100 megahertz instantaneous and occupied bandwidth. And we can activate the DPD. And when we activate the DPD, you can see the feedback trace from the PA on the right-hand side here. And again, you can see the linearized performance from the feedback path once we've activated the DPD. But we can measure the performance on our signal analyzer. So what we're looking at here are those 5 LTE-20 carriers at the output of the PA. This is pre-correction. And once we activate the DPD, you can see the yellow trace, and you can see excellent performance there in terms of adjacent channel power. So we repeat the test, but instead of LTE carriers, we're using one 100 NR 5G carrier here. So again, 100 megahertz instantaneous and occupied. We activate the DPD, and you can see the linearized performance in the trace on the right-hand side there, the feedback from the power amplifier. And again, we can look at our signal analyzer and measure the corrected performance at the output of the power amplifier. So once we activate the DPD, you can see the yellow trace here, which is the corrected performance. And again, we're measuring excellent adjacent channel power, over 50 dBc ACLR performance there with the DPD. So one more harder use case here where we are generating up to 200 megahertz of instantaneous and occupied bandwidth with 10 LTE-20 carriers. So when we activate the DPD running at a higher sample rate here, 737 megasamples, we can see the correct performance. And now we look at the signal analyzer. And once we activate the DPD, you can see the corrected performance in the yellow trace. And again, 50 dBc, excellent performance in terms of adjacent channel power correction. And finally, we will use our NR carriers, in this case 2 NR100 carriers, to look at the performance of the PA with the 5G signaling. Again, we activate the DPD here, and if you look at the trace on the right-hand side, it's the output of the PA, the feedback path, and you can see the linearized performance of the power amplifier. But let's take a look at the signal analyzer. So there are 2 5G carriers there, 100 NR carriers. Now we will activate the DPD, and the yellow trace will show the corrected performance. And again, as highlighted, excellent adjacent channel power performance. So in the demonstration, we've seen how we can improve the PA efficiency and performance for 100 and 200 megahertz use cases using a 5G NR carriers. To find out more information about any of the components or aspects covered in the demo, please visit the links shown on the screen here.